Okay, so as I said, I'm going to do just some videos here on the, or sorry, some exercises on this video, just a couple of examples of the next set of problems that relate to section 1.4. As you saw from the last video, these problems are going to be a little more in depth, but there's not going to be as many of them, but they will take a few more steps, when you're doing this. So again, I'm back in the course, assignments, and at this point I'm assuming most of you are done with the quiz. We're on to the next stuff, so you should be through 1.3. We watched 1.4. Now we can do some problems out of 1.4. So let me just I'll pick up right where I left off here. Number 33. Okay, so in this one, for the following polynomial function, find the degree of the polynomial, all the x-intercepts, and the y-intercept. So the degree, remember, the highest number that you have, the highest power you have, that's your degree. Be aware, the only thing I'll warn you at, they don't usually try to do this on purpose, but sometimes these terms will be out of order. So it's a good habit to always be writing this in descending order. So if they give you a problem, don't just take the first term, look at all of them and find the highest power. Now the x-intercepts, on that particular one, remember, that's where we're going to set the function equal to 0. So we solve this. We are just going to factor it out. And of course, you can always use your quadratic formula, but that will take a little bit longer considering what problem you have here. It's one that's a little bit nicer. So it looks like my two intercepts are 4 and -3. Now usually it doesn't matter which order you put them in, just remember you put them both. Use a comma, and again, they're asking for the intercepts, not points. They just want the values. So we have those. And part C, the y-intercept, which is supposed to be the easiest one. Remember, that's where you find f of 0. So we get a 0 minus a 0 minus a 12, and you'll start to get the hang of it that it's always going to be the constant number that's by itself. That's always going to be your y-intercept. So you can write it out, you can do it in your head, you can just eyeball it. Either way, you have the answer. Okay, so let's look at number 39. I'll just skip around. I'll kind of go by 4s like I did the other day, just to give you a nice sample of what's going on. So we have a graph here, and I'll enlarge this. And they're asking us what is the minimum degree of a polynomial function that could have this graph? Okay, so the minimum degree, remember, this is kind of going backwards, but they talked about it. If you have a degree, there's at most one less turns. So if you count this right here, here's a turn. Oops. Try again. So here's a turn, here's a turn, here's a turn, another turn, another turn. There are 5 turns. So the rule was the degree has got to be at least one more than that. Now, it doesn't mean that there's always exactly one less turn, but if your degree is 6, then you can have 1, 2, 3, 4, 5 turns, but you can't have anything even or more. So this question is pretty much the same thing. They're just asking what's the minimum number of the degree. It has to be more than the number of turns. So if we had 5 turns, it's got to be at least 6. It could be higher, but it can't be anything below 6. And then last, they say, is the leading coefficient negative or positive? So now we got to think about how that was, what the rules were on that one. Okay, so let me pull up this picture again and try to enlarge it for you guys. Okay, so remember, this is because the top of the two ends are the same, we know it's going to be even. The degree is even. Excuse me. So the highest power is either going to be 6 or 8 or 10 or something like that, but it's got to be an even. And remember, that's because of the end behavior. The graph starts and finishes up top at the same spot. So on an even polynomial, if they're both pointing up, then you know that first term has to be positive. If they're both pointing down, it would be negative. So this one's going to be a positive. That's all it is on this one. Not too bad. Okay, so number 43 here. Okay, they want us to use a graphing calculator for part of this, so I'm going to pull out the Desmos again. And remember the graphing calculator is not going to be essential for your quiz problems. I have I may put a couple easy ones in there knowing that you can pull up a graphing calculator or use your own. But I mainly want to make sure you know how to do the concepts. You want to make sure you can do this stuff without the calculator. So these are the important ones. So here's our function. First question, what are the x-intercepts? All right, so our same rule. Here is our function right here. And I always recommend doing a little rewrite. Now the rule is to find the x-intercepts, you set the entire polynomial equal to 0. Now we already knew, I should have written up here, our domain is going to be all real numbers, but you can't have a 1. That's the only number you can't have. So in order to solve this, it's actually easier than you might think. For a fraction, all you have to do is let the top equal to 0. But if you're not sure, I can multiply both sides by x minus 1 to make this cancel. And the left side is going to be just 0 times that. It's still a 0, but now we get a 0 equals 4x, and solve for x equals 0. This is your x-intercept. Okay, there's only one of them, just that one, and that's going to be the x-intercept is 0. Sometimes you get none of them, and you'll know it because you won't be able to solve this. It'll probably be like an irrational number or an imaginary number, something like that, something that you can't do. But we did get an answer. We got a 0, so we have one intercept, and that's what it is. Now they asked the y-intercepts, and as I talked about a second ago, that's supposedly going to be the easier thing because a y-intercept, you may not be able to eyeball this one like we did on the previous homework problem, but on this one, all we have to do is plug in 0 for x and see what you get. So we're going to take f of 0, and that's going to be the thing we calculate, because for all y-intercepts, the x is 0. We get a 4 times 0 is 0 minus 1, and you'll see we get a 0. We already knew that point existed, the 0, 0. Sometimes when it goes right through the origin, you're going to get an x and a y-intercept right there, and that's what you have here. Okay, and remember, at most, you're going to have one y-intercept. Sometimes you don't have, once in a while you don't have any, but on these polynomials, you're going to get one. On the rationals, sometimes you don't have any y-intercepts, but this time we do have one, and it happens to be the same point. It's going to be at 0. And that's it for this problem, okay, or for this part. They did ask us to graph this. Oh, here we go. Okay, I'm sorry. I got a lot more to do. Determine the domain. Well, I already wrote that up here, if you recall. The domain is everything except for 1. So the domain is all real numbers, almost. The domain is not defined. Very rarely is that going to be the answer. It's usually going to be this one. It's going to be all real numbers except you can't have a 1. And if there's more than 1, just put the comma and check them all. Okay, and then part C, what are the vertical asymptotes? Remember, the domain correlates exactly to the vertical asymptotes. So whatever you cannot have is going to be the vertical asymptote. X equals 1. The exception was that one problem, or sometimes you'll see these problems where when you factor the top and bottom, something cancels off, then those are no longer vertical asymptotes. But if you factor everything and then whatever makes the bottom still equal 0, those are your vertical asymptotes. So we're going to get that x equals 1 again. And then also, what's the horizontal asymptote? So let's look at that original graph again. We have f of x equals 4x over x minus 1. Remember the trick. Look at the powers, the degrees of the top and bottom. They're both degree 1, which means I can just take those two, cancel the x's, and what I'm left with, that's my horizontal asymptote, the y equals 4. It's always easy when someone else is doing it, I understand that, but you'll get the hang of these as you do more and more of these. Now we have to choose the correct graph. Now, they wanted us to graph this, with a graphing calculator, and you realize that some of these are very similar, but they're not exactly the same. You have to find that distinction. So remember your asymptotes without even using a graphing calculator. Okay, I got my 4 choices. I know there's a vertical asymptote at 1. So if you look at this one, here's my x-axis. It looks like they have a vertical asymptote at -1. So I'm not going with that picture. on this one, here's my y-axis. Here is a vertical asymptote of 1. So that one's possible. Look at this one. Also vertical asymptote of 1. That's possible. And on this one, we're back to a vertical asymptote at -1, so it's not going to be this one. So I've eliminated a couple. Now we look at my horizontal asymptote of 4. Okay, here it looks like it's below the graph, so that's not it. Here, it looks like it's above it. And what's deceiving is these hash marks are counting by 1s on the x-axis, it looks like. These, I believe, are counting by 5s on the y-axis. It's not exactly clear, but at least you can tell this one's above the x-axis, this one's below. Therefore, C should be our answer. Now, to take it a step further, what you should always do is, okay, we have remember our intercept, our x and y is right here. Next, you just need to plot a few more points. Okay, we'll get into that more in the next section, but the trick is, go get a table and just plot a few points. You should know the end behavior is getting closer and closer to the number 1 on both sides. Go plot 5, 10, 15, 20, something like that, just to see that you're above it and below it. And then it's always important to see what happens around the vertical asymptote. Now we said it's x equals 1, but you want to find out what's going on right next to it. And I don't mean 0 and 2, I mean what happens at 1.1. What happens at 0.9? Numbers that are really close. And I know you're not liking decimals and fractions, but that's the true way to learn what's the behavior around the asymptote. Okay, so let's look at a couple problems over here. Check out number 47. Okay, so it's a similar problem. We have a rational function. Remember, a rational function is the one that has a fraction. It's like a function over a function. And they want us to determine all pretty much the same things here. Now, remember that mistake I made the other day. Read each part of what they're asking one at a time. Don't go by what's asked in the original question here. They have specific order they want us to fill things in. So, first part, select the correct choice, horizontal asymptote. Okay. So remember the rule for horizontal asymptote. We look at our powers here. Highest power is 3, highest power is 2. If the top has a higher power, that's that scenario where there is no horizontal asymptote. Okay? Part B. What are they asking? Oh, sorry. Select the correct choice. And they answer a lot of things. They're all about the vertical asymptotes. So what I'm going to do, sorry, I hit the wrong button. Let's go back. I knew our problem looked like it was different. Apologies. That's all they're asking, actually. Okay, I missed something. They're only asking the horizontal asymptote. Sometimes we get away with it. Let's just look at 48 since we're here. Now they're asking this one about vertical asymptotes. Okay, so on this one, we have this new equation. I'm just going to write that over here just to get us a little more familiar with what we have. Okay, now one of the first things I'm going to do in order to find the vertical asymptotes is I want to factor the top and the bottom. Now remember, this is a sum. It's an addition. It's not the difference of two squares, so you cannot factor that top anymore. The bottom, though, is a difference, so I can factor this into x plus 7, x minus 7, and this into x plus 5, x minus 5. So that tells me, and nothing's going to cancel out. X squared plus 7 does not cancel with x plus 7, so nothing cancels. And I see for my domain, I'm not allowed to have -7, +7, -5, and +5. All these are my taboo numbers, all my bad numbers that I cannot use. Okay? So now, because nothing cancels off, every one of these are vertical asymptotes. X equals -7, x equals +7, x equals 5 and -5. So my answer is there are going to be 4 vertical asymptotes. Should not matter which order you type these in. And we check them out. Uh-oh. What did I miss here? Okay, let's see. Oh, I did not read that right. I said you didn't have to put it in the right order. It does say right here in order from left to right. So let's fix that. -7, then -5, then 5, then 7. Usually they're not that picky, but they're still not liking something up here. Okay. Okay, now I can't say this enough. I'm learning sometimes as I go with this system, and this is why we're doing the homework. Read it carefully. I figured out my mistake. See if you did. In order from left to right, they want their equations. So remember how equations look. Vertical asymptotes are x equals -7, x equals -5, x equals 5, x equals 7. And I hope that's going to be right. That's my final check. And now we finally get it. So we had the right answer in the beginning. They just wanted a specific format. And this is important to you, all of you, because learn these nuances, because if this same problem was on the quiz, I would have gotten it wrong. You know, you would have gotten it wrong if you did the same mistake I did. But learn from this, so the hope is that when you see a problem just like this, you'll remember to read this carefully and answer what they want. Okay, let's check another one of these. Okay, let's try number 51. That's where I was aiming. So now they want us to find equations of any vertical asymptotes of the function. So it's the same thing. Our function is going to have a little bit more powers to it. It's going to have a couple more steps, but it's the same exact idea. Okay, just like I did here, the part that I'm erasing. You have a function, and you want to factor that denominator as the first thing, because that's going to tell you what's in and not in the domain. Because all those points that don't exist in the domain, those usually are going to be what are the vertical asymptotes. Okay, so now I factor that bottom. I'm first pulling out an x. So I get an x squared minus 64. Then I'm going to keep, I'm ignoring the top for a second just because I want us to make sure we're all understanding the denominator. And I'll do this a lot. I work with the denominator because that tends to be the more important part of any function. So I continue factoring. I get x plus 8 and x minus 8. And don't forget that x out front. Now you also have to remember we need to factor the top. So when I factor the top, what happens is this x and this x cancel. Now, it doesn't mean it's now a good point, but what it means is it's not going to be a vertical asymptote. These bottom ones are my only ones that are going to be vertical asymptotes. So I'm going to have the x equals -8 and the x equals +8. Compare that to the actual domain of the function, which says, sure, you can't have -8, can't have +8, but also 0 is not allowed in the function. And a lot of people have a little issue with this. It's not a vertical asymptote, but if you go to the original right here, you try plugging in 0, and you're going to see that it's not going to work. It's going to give you a 0 on the bottom. So that's why it cannot exist in the domain. But in terms of vertical asymptotes, we have to cancel everything first. Then what's left, those are my vertical asymptotes. So my vertical asymptotes are x equals, and this is a weird one. They don't want the full equation. This is the one where they want the numbers separated by commas, 8 and -8. And there we go. Okay? So let's look at number, say, 55. All right. Company is manufacturing snowboards. The fixed costs are $100 per day, and total costs are $5,500 per day. $100 per day and $5,500 per day at a daily output of 20 boards. Okay, assuming the total cost per day CX is linearly related to the total output per day, write an equation for the cost function. Now you have to decode this a little bit in what they're asking. So they tell you the fixed costs are $100. So when I'm making my cost model equation, that 100 is always going to be there. The other part is going to be something times X for how many snowboards you sell. Okay, we need to figure out what that number is. Now what they did tell us is this is going to be 5,500, that variable cost, but that's when X equals 20. So we have to do a little bit of work here. We just know that if you take 20 and you multiply by whatever this variable cost is, sorry, let me change that to new variable. I'm going to call it V here. Whatever that variable cost is, I know when we multiply it by 20, we're going to get 5,500. So we just divide by this. We use that one factor they told us to figure out that it's going to be what? 2, 5. I'm getting wrong. And like I said, don't be afraid to use your calculator here. Okay, so figure make sure we get the right number. Don't try to do this in your head like I was trying to do quickly here. And we get our 275. I don't know where I missed that. So what that's saying is that's your cost for each board, per board. If you sell one board, it's going to be $275. If you sell 2 boards, it's going to be $550. We sold 20 boards, that's why it was $5,500. So they didn't give you this formula, but they gave you a method to solve it. So we say C of X is going to be the $100 fixed cost plus 275 times the number of boards. And check it if you're not sure. If you plug in 20 to this, that second term becomes 5,500. If you plug in 2, it becomes 550. But this is your cost model right here. Okay, and that is the first question. I think that might be the only one, but we'll see. And, oh, what did we get wrong here? Okay, so let me clarify. I see what we did wrong here. What I did wrong. Got to read these words carefully. We know that, let's get to the basic cost model. Okay, there's going to be a variable cost and there's going to be a fixed cost. So we have a fixed, and then we have a variable cost, which we're going to multiply by X. So it doesn't matter what you call it. Let's just say I call that F and I call that V times X. That's your general model. Okay, so what they told us was, they gave us the fixed cost of $100. So I know that that's going to go in right here. What we don't know is the variable cost, but so we're trying to figure that out. What we do know is there were 20 boards made that day. Now that 5,500, I made a mistake. What that was the total cost. That's what goes over here. Total cost was 5,500. So we need to solve this. And it looks like it's going to be 270 equals V. We've now found that variable cost, what it is. So now when I can go back to my original model, I can clean it up and say, well, there's 100 fixed cost. There's the 270 times the number of boards. That's what it was. 5,500 wasn't that variable cost. It was the total cost right there. So I had a little fix. I just had to change that to a 270, and now we have the right answer. Okay? Now the average cost per board for an output of X boards is given by this C with a line over it. That usually means the average. Okay? So they just want us to find the average cost function. All that is you're taking C of X and you're dividing it by X. So see this part down here? Let me get rid of the calculator and I'll show you exactly what we need to do. Average cost is going to be Cx over X. Well, we have C of X, which is the 100 plus the 270X. We divide that by X, and that's going to be, probably simplify it to this. Sorry. You can make it 100 over X plus 270, or I would just leave it as that original function right there. That's all it is. So, little bit again with your homework to learn how to type in that fraction, because you can type something like 100 plus 270x. And if you hit the slash, it only puts the division over the second term. So the trick is you got to hit this from this palette, hit that right there, and that makes a fraction where you can put the 100 plus 270x on top and the x on the bottom, and there's your average cost function. Now they want us to sketch this average cost function. Now remember, look at this function that we just created. This one right here that I circled. This is one of those rational functions that we're dealing with. Okay, that one right there is an average cost. That's a rational function. So think about the rules on this one. We know x can't be 0, so there's going to be a vertical asymptote right there. Let's look for the horizontal asymptote. And remember the trick? Look at the highest term of each. They're both 1s, so we take the 270 over x divided by x, and it looks like we get y equals 270. That's the horizontal asymptote. So look at my different functions. This has a horizontal asymptote. It looks like that's somewhere up there, 50, 100, 150. Yeah, these are all hundreds. So they've got it at 200. Looks like it's a little bit low, so I don't think it's that one. This one's got it at about 300. That doesn't look right. This one has it, looks like that's our 270 right there. And this one looks like it's really low at 100. So out of all these, this is the only one that has the correct one. And then the other thing you can do, you can just plot a couple of points. Whenever you get this multiple choice, if you're not sure, you're not able to deduce it like I'm doing here, go plug in a couple, and this might actually help us. Go plug in a couple of values just to see what you get. So the easiest one, go plug in 1. 1 looks like it's the lowest it's going to be. So plug in 1 into this function, and we get 370. And look where it lands. 100, 200, 300, this is not right. 370, that looks like it's 400, but it could be 370, so not sure. That looks like it could be 370. This one, I can erase that. That also looks close. So plot another point. Okay, we're from 1 to 30. Let's try, these looks like they're counting by 5, so maybe I'll plug in the number 10 right here. So when you plug in 10, you get 2,800 divided by 10, so it's 280, and that will really help you figure out which one it is, and it looks like C is our only choice. And there we go. Okay, and the last part, what does the average cost per board tend to be as production increases? Well, that's just saying, remember, this is the average cost per board in the beginning when you make a few. Now let's pull this up. This is our proper graph right here. Okay, this is the exact graph of the average cost. And it makes sense. When you only make 1 or 2, it's pretty expensive. This is any business, but as you start mass producing, your cost goes down because it sort of absorbs those fixed costs. So the more and more you make, the less it becomes, but it's never going to get lower than this asymptote, and that asymptote is your 270. That's what your cost becomes over time. And that's what we have. Okay, so I'm going to stop there on the example problems. The rest of them from 56 on to 80 something, those are going to be out of section 1.5. I'll do like I did here. I'll record a lecture video, and then I'll record some example problems, either 2 separate videos like this one or all in one. All right, again, if you have any questions, email me, let me know.